Well, hello, Math 3-2. Next lesson here, we're going to talk about characteristics of polynomials a little bit more in depth before we talk about what the graphs look like and some characteristics like end behaviors, turning points, range, domains. This first little piece here is just a little matching activity. I want you guys to try this out. If you haven't already done so, just pause the video, try to do the little matching. There's something new here. We're talking about leading coefficients. Just by process of elimination, you should be able to figure out what that one is. And I'll see you in a bit. So give it a little pause. Hopefully you tried that out. So the x-intercepts, let's go through. Maybe we can read the definitions and try to match it to these because these are a little bit easier to read. So a function, it contains only operations of multiplication and addition with real number coefficients and whole number exponents and two variables. Yeah. That was the whole definition of a polynomial. So I'm going to call this one A. Cool. Cross that off. Where the graph intersects the horizontal axis, which is y is equal to 0. So remember we said before, when y is equal to 0, that is our x-intercept. And that's the horizontal axis, right? Cool. Okay. Describe the shape of the graph from left to right in the coordinate plane. So that is your end behaviors. Remember when we said like from quadrant 3 to quadrant 1, those are kind of end behaviors there. Represents the value of the independent variables of the function. Independent variables of the function. That's a weird word, independent variables. Independent variables is another word because it starts with the word input. It's also another word for x. So all my x values are my domain. Remember that would be like XER instead of all the x values. Represents, I'm just going to go down here because this represents the value of the dependent values. The dependent ones are the outputs. And these are the y values. So this would be h. Okay, let's go to that. Where the graph intersects the vertical axis. Oh, what did I do here? Oops. H would be this one down here. Where it crosses the vertical axis. That's the y-intercept where it crosses the vertical axis. Okay. The coefficient. The coefficient of the term with the greatest. That's kind of leading. The coefficient, leading coefficient of the greatest degree of the polynomial. The leading one, the one that would be in front. Kind of makes sense. That would be f there. We have one last one here. This is probably g, but we should just double check. At any point when the graph changes from increasing to decreasing or decreasing to increasing, so like those points of the graph here and here. Yeah, so those turning points. There we go. Looking pretty good. All right. So here's a few different terms and glossary terms that we should know about a polynomial. So most polynomials we're going to deal with are going to be in standard form. So like a function that's not in standard form would be something that looks like this. This is just a quadratic from Math 20. This is not standard form because I don't want parentheses in my graph. So this is not a standard form. A standard form would look more like this. That would be more standard form. It doesn't have any parentheses in it. So this would be a standard form. Other standard forms, other things that are not standard form would be things that are factored, like x minus 2 and x plus 3. That's the factored form of a quadratic, but that's not standard form. That's factored form. The middle one here is called vertex form. This one here is called factored form. This is standard form. It's also equal standard form because it's equal to y. The f of x is on this side, so it's y is equal to, with no parentheses. If it was equal to 0, that would be general form. It's a different thing. We don't talk about general forms here. We always make y is equal to. It makes things a little bit easier for us. The definition we already had up there about the leading coefficient, it's just the number that's in front of the greatest degree, the greatest exponent in the polynomial. So like this top one here, this example would be 2. So this would be our leading coefficient. Not the greatest number. 5 is the greatest number here, but the one that's in front of the one of the highest degree. Spell coefficient correctly or not. So this has the highest degree. This is a degree of 2, because that's the biggest degree, and the number in front of that is 2. Technically, it's positive 2. We'll talk about what that positive would do for the graph later on. The constant term is the term with no variables in it. So this last one here, this -3, that's my constant. It doesn't have any variable. Technically, it does. It's x to the power of 0, like we were talking about in the last video. But you don't see it there, so we say it doesn't have a variable. It's very much like a constant graph. It didn't have any x value in there, so it just gave you that flat line. This doesn't have an x value in it. It doesn't change because of when you change the x values. So when we're doing this, we want to figure out, what does this do? What do all these things do? What does the constant term do to the graph? What does the leading coefficient do to the graph? And we're only going to be looking at standard forms for these ones. So we're going to look at these 2 linear graphs here. Okay? So we're going to put these into our calculator, and then we're just going to look at those graphs. And what I'm going to do that is I am going to pull a Desmos to do this. My face is going to get in the way. I'm going to put my face right here. Okay. Let's get rid of that. So the first graph, 3x. Oh, there it is, 3x, a nice little straight line. So I'm just going to give that a little good sketch right here. There's my x and a y axis, and I put a line. Now it looks like it crosses through the origin here, and it's going up at a pretty steep line. So there's my nice little straight line. Just a sketch. I'm not too worried about how perfect it is. I'm not going to answer too many questions on that one. I'm just going to go right over to this one and see what happens if I put a negative in front. -5x. My leading coefficient is a negative. Oh, okay. So let's put my x and y axis here. And it's going downwards this time. So from left to right. Still crosses the origin, but it's going this way this time. Okay. We've got our 2 graphs. We've got them nicely sketched out here. I'll come back to that Desmos later on. Now let's analyze these 2 and see what's happening. The number of x-intercepts for both of these. Well, you notice they cross the x-axis once each. Y-intercept, 0, 0, 0, 0. You could just say 0 as well. Don't have to worry about that. Now the key part is, what's the difference between the endpoints? So this first one's starting off in this quadrant down here. Remember, this is 1, 2, 3, and over here is 4. That might be useful for later. So it starts off in quadrant 3, and then goes up from left to right to quadrant 1. Look at the other graph. It starts off in quadrant 2 and goes down to quadrant 4. All right. These are just regular polynomials. So XER for my domain, XER for my domain. My range, these are just regular linear graphs. So these are going to be YER. You be formal, or you don't have to be formal, so you just say YER. It's fine by me. On the number of turning points, you notice that this graph is continuously going up or continuously going down. There's no points where you're going back up on itself. So 0 turning points. The graph represents a linear polynomial function. Nice little straight line. Cool. So, takeaways from this. Pretty much the only thing that changed between these 2 is which way the end behaviors are going. A positive leading coefficient, I'm going to put it over here, my leading coefficient is positive 3, and on this one over here, my leading coefficient is negative 5, so that number that's in front. You can see that this is a positive leading coefficient as a positive slope, so it's going upwards from left to right. This is a negative leading coefficient, so it's going downwards from left to right. That might be something useful to know, something probably an easy indicator if something is which direction the graph is going if you know the leading coefficient. Or vice versa. If you know which way the graph's going, then you know what the sign of the leading coefficient should be. Okay, so let's look at a few more of these graphs, and these ones are quadratics. Let's look at some quadratics here. Let's move my face out of the way. So we're going to have a negative x squared here. Oh, just 1 second.